Hey everybody, today we are going to start to review for your exam. This was a little cheat sheet that Mr. Kate made up, and it just goes over every single rule. So remember, anytime that you are multiplying, you add your exponents, but it must only be with the same base. For division, you subtract the exponents of the same base. When you raise a power to a power, you multiply. And remember, with negative exponents, you flip them or change the location over the fraction bar. So you should always have this sheet handy when you are studying for this exam. So if we're starting to go over the answer key, or the review, when multiplying with the same base, remember you add your exponents. When dividing with the same base, you always subtract. When raising a power to a power, you multiply. When a negative exponent is encountered, you flip or change the location. When a negative base has an odd exponent, the final answer will always, always, always be negative. When a negative base has an even exponent, the final answer will be positive. So basically think even and positive go together, odd and negative. All right, let's get into the actual math problems right now. So simplifying the expression below. A lot of you want to do 5 times 5, but that's not the case here. 5 is your base. So remember, you leave your base the same. Since we're multiplying, we add our exponents. So 4 plus 6 would give you 10. So 5 to the 10th power is your answer. For number 2, we have 2 different bases. So remember, you can only combine exponents if they have the same base. So for number 2, I would have 2 to the 3 plus 4 power, which gives me 7. Times 4 is my other base. I have a 5 plus, remember, if there's no exponent shown, put a 1 there. So 5 plus 1 would give you 6. Number 3, remember, since we are dealing with negative bases here, you must use parentheses. So my first base is negative 2. I have 10 plus 12 to give me 22, times my other base is negative 3, and this time I would be adding 7 and 17 to give me 24. For number 4, the operation shown here is multiplication. So remember, when you multiply, you actually multiply your coefficients out in front. So I would do negative 10 times 2 times negative 3, which gives me positive 60. Look at one of your variables. One of them is m. So m to the 6 plus 2 plus 1 gives me 9. And then I have y to the 2 plus 3 gives me 5. So that is my overall answer. Number 5 is very similar. I multiply my coefficients, my values out in front. 10 times negative 5 is negative 50. My only variable I see here is h, and I would do to the 2 plus 5, which gives me 7. First page complete. Next page, number 6. So a lot of students I know when I was walking around had trouble with this one because they see this negative w right there. So treat that as if the variable, the same way as if the variable didn't have an exponent. So if you see a negative in front of your variable, put a little 1 there. So that would be treated as negative 1w. And likewise, if it helps you to put a 1 in front of this w, feel free, but it's not necessary. So when I multiply my coefficients, I have negative 4 times negative 1, which gives me a positive 4. W is a base, a variable base, so I add my exponents. 6 plus 2 plus 1 gives me 9. Y is another base. I only see y to the 4th here, so I'll keep that the same. And S, I have a little 1 here, plus 3 gives me 4. Remember, if you wrote something like this, 4w to the 9th, s to the 4th, y to the 4th, that still works. The order of your variables does not matter as long as you have the correct exponent with them. 7 is also multiplication, so I multiply my coefficients. 10 times negative 7 is negative 70. V is a base, and I would do 5 plus 6, which gives me 11. U, I only have the u squared. Number 8. Once again, multiply your coefficients. 3 times 9 times 2 would give you 54. I have I as a base, so it's 3 plus 6 plus 2 gives you 11. Then my other base would be n, and for n I have 2 plus 4 plus 2, which gives me 8. Excuse me. Number 9. Once again, multiply your coefficients. 4 times 3 times 2 gives you 24. I have an x as a base, so this time I could do 2 plus 1 plus 3, which would give you 5. And y, I only have that one. So technically it's y to the 1st. However, you just might write this, and you'll see it in textbook like this. 24x to the 5th y. That y to the, like the little 1, remember, for your exponent is not needed. Keep on going with these multiplication. So if I multiply my coefficients, negative 8 times 3 times 2 gives you negative 48. I have a base of a, so I have 1 plus 2 plus 2 gives me 5. And then b to the 2 plus 2 gives me 4. 11 threw kids for a loop a little bit as well because of the negative x here and the negative x there. Remember, just put a little 1, so it's like negative 1x, negative 1x. First thing we're going to do are multiply our coefficients. Negative 3 times negative 1 times 2 times negative 1 is negative 6. X, I have a 1 plus 2 plus 2 gives me 5. And y to the 1 plus 1 plus 2 gives me 4. Here we go, we're getting on to division this time. So for number 12, 7 is my base. So I'm going to leave 7. And remember, when we are dividing, we subtract our exponents. So 8, and you could think of this fraction bar right there as a subtraction sign to help you to remember to subtract your exponents. So 7 minus 3 is 5. 13, my base is g, and for my exponents, 7 minus 3 gives me 4. 14 is a two-stepper. So what I like to do first is multiply, or follow the rules for multiplication, which are in my numerator. So if I do that, if I multiply my coefficients, 2 times 4 is 8. X to the 2 plus 2 would give me 4. And I'm just going to rewrite y to the 3rd because that's all there is in the numerator. In my denominator, I have 2xy. Now I can follow the rules for division. So when I divide, remember you divide your coefficients out in front. So 8 divided by 2 is 4. For x's, I have 4 minus 1, which would give me 3. And for y, I have 3 minus 1, which gives me 2. 15 is just like 14. It's a two-stepper. So the first thing I would do is multiply what's in my numerator. So I would do 8 times 5 is 40. A to the 1 plus 2 is 3. B to the 2 plus 4 gives me 6. I'm going to rewrite what is in my denominator, 4a squared b to the 4th. Now I can follow the rules for division. So remember, you divide your coefficients out in front, these values right here. So 40 divided by 4 would give me 10. A, remember when we're dividing we subtract our exponents. 3 minus 2 would give me 1. And B, 6 minus 4 gives me 2. And your final answer would be 10ab squared. 16. This is just straightforward division. So the first thing I would do is divide those exponents. So 48 divided by 3 is 16. For x, I only have this x to the third power. There's nothing in my denominator, so I rewrite that. Y to the 2 minus 1 would give me 1. And the z's are exactly the same in my numerator and in the denominator, so I just cancel them out. So your final answer would just be 16 x to the third y. Remember for 17, anything to the 0 power, especially because it's in the parentheses, because if you would distribute that 0 to everything inside, everything would be to the 0 power. So in this case, your answer would just be 1. For number 18, number 18 deals with a power to a power. So the first thing I'm going to do is distribute that 6 into everything. And remember, when you distribute or raise a power to a power, you multiply. So we would have x to the 30th over b to the 10 times 6 is 60th. That's your answer. Number 19, same thing. First, you must take this 4 that's out of the parentheses and distribute it to every single term inside. So I would have negative 4 raised to the 4th power because you actually raise your coefficient to that power. Make sure to remember to put this negative 4 in parentheses because your base was negative. And then m to the 5 times 4 is 20. D to the 2 times 4 is 8. However, you are not done yet. You have to find out what is negative 4 to the 4th power. So you can either figure it out in your head, use your calculator. Your final answer would be 256, m to the 20th, d to the 8th. Number 20, same thing. We're going to distribute this 5 to every single term inside. So I would have negative 3 raised to the 5th power. X, 2 times 5 is 10. Y to the 1 times 5 is 5. Make sure you actually raise negative 3 to the 5th power, which would give you negative 243, x to the 10th, y to the 5th. For 21, oh my, you have a negative exponent. Remember, you can never have a negative exponent for your final answer. So you flip it over the fraction bar or change its location. If it helps you to put this over 1, feel free. So now I know that this is in my numerator. So I'm going to bring it to my denominator. Remember, when you flip it over that fraction bar, your exponent becomes positive. There's nothing in my numerator, so I put a 1. For 22, the only value with a negative exponent is a b because it's not in parentheses. So that 33 is going to stay in my numerator. B to the 12th would change the location and go to my denominator. Okay, 23 is a biggie. So for 23, there are different ways to do it. One way you might want to distribute everything. So if I do that, I have negative 10 to the negative second power times b to the 1 times negative 2 is negative 2. And m to the 2 times negative 2 is negative 4. These all have negative exponents, so you must change the location. These are all in the numerator, so they all must go to the denominator. I'm going to put this up here. So in my denominator, I would have negative 10. Remember, when you change the location, the exponent becomes positive. B squared m to the 4th. There's nothing in my numerator, so I put a 1. But remember, you're not done yet. Negative 10 to the second power is 100. So your final answer would be 1 over 100 b squared m to the 4th. For 24, the only variable with a negative exponent is the x, so that's the only one that has to change the location. So 2p is going to stay in my numerator. I'm going to change the location or flip where that x value was, so I'm going to put it in my denominator, and remember, once you put it in your denominator, that negative exponent becomes positive. 25. Different ways to do it. I might start off with distributing that negative 6 to every single value in there. So I would have b, 3 times negative 6 is negative 18, over d, 8 times negative 6 is negative 48. Once I have that, they both have a negative exponent, so they both need to change or flip the location over the fraction bar. So d would become in your numerator, and I would make it to the positive 48, and b would go to the denominator, and it becomes positive 18. 26. Please, for 26, keep your bases. So, and remember, I am dividing. So for 3 is a base. I'm going to do 5 minus 3, which gives me 2. Times 4 is another base. You could either do, I'll do it one way and then I'll talk about another way. 7 minus 9 is negative 2. And then you just have times 7. I'm not done yet because this is a negative exponent. You cannot have that in your final answer, so it must change locations. So 3 squared times 7 could remain in my numerator. The 4 to the second power goes to my denominator. If you wanted to simplify it a bit more, you could. 3 squared is 9 times 7, 4 squared 16, and so forth. Technically, if you wanted to do 9 times 7 to give you 63 over 16, but really on the exam, we're probably only going to make you do that. Another way to think of 26 is, if you don't want to deal with this negative exponent, look in your problem. You know you have to subtract. Well, 9 is the larger value, so how many more would be in your denominator than in your numerator for the 4s? Well, 2 of them, because 7 plus 2 gives you 9, or 9 minus 7 is 2. So that's why the 4 to the second goes to the denominator as well. 27, we're dividing, so we subtract our exponents. So for k, we have 15 minus 23 is negative 8. And for j, we have 10 minus 17 is negative 7. They both have the negative exponent, so they both have to change or flip over the fraction bar. So k to the 8th would go in my denominator, and j to the 7th would also go to my denominator, because they both had negative exponents. There's nothing in my numerator, so I'll put a 1. If you didn't want to do this step, you could think in your head, well, 23 is larger than 15 by how many times? 8. So that's why the 8's in my denominator. 17 is larger than 10 by how many times? 7. That's why 7's in the denominator. So I hope this video helped you review for your exam. If you have questions, please make sure to ask your teacher. Please study. This is a very big test, and we want you all to do well on it. So good luck, and ask us if you need any additional help. Thanks, and have a wonderful day.